Hi, I'm Walt Venable. Welcome to my Capstone project for the 5-day Gen AI intensive course with Google. This project is called RAGLab, a tool I created to help AI developers evaluate and compare different RAG pipeline configurations automatically. In this short video, I'll show you what RAG is, how RAGLab works, and what I discovered while building it. RAG stands for Retrieval-Augmented Generation. It's a technique that helps AI models answer questions more accurately by pulling in relevant information from an external knowledge base. This makes the model better informed and more reliable, especially in specialized domains like law, medicine, or finance. Instead of just relying on what it already knows, the model uses real data in real time to answer the user's questions. Here's how it works, step by step. First, the user asks a question, something specific to your domain, like a company policy or a local procedure. In step 2, the system takes that question and queries a knowledge base. This could be a vector database of documents to find relevant context. In step 3, the knowledge base returns related passages, snippets of text that might help answer the question. In step 4, the original question and the retrieved context are passed together to the language model. And finally, in step 5, the model generates a well-informed answer based on both the question and the supporting information. That's what makes RAG so powerful. It gives the model just-in-time knowledge so it can reason with real facts, not just what it was trained on. As we saw in the last slide, RAG started as a pretty simple idea. Grab some relevant documents, pass them into a language model, and get a better answer. But the field has evolved quickly. Modern RAG systems have added more stages, like pre-retrieval, where the user's question might be rewritten for clarity or context, and post-retrieval, where we might compress or re-rank the retrieved content. And at each of these stages, there are now multiple tools and techniques available. This is great for performance, but it also means the number of possible combinations can explode. Instead of one RAG pipeline, you've now got dozens of possible configurations. Different query rewriters, retrievers, re-rankers, and generation models, all of which might behave differently depending on the domain you're working in. And this creates a real challenge. How do you know which combination works best? Testing them manually is slow and repetitive. That's what led me to build RAGLab, to automate the comparisons and help developers quickly find the best performing setup for their use case. So what does RAGLab actually do? It automates the process of comparing different RAG pipeline configurations. You provide a set of domain-specific questions and sample answers, if you have them, along with specific evaluation instructions if desired. Then you define a list of modules to test, things like different prompt rewriters, retrievers, and generation models. RAGLab then builds every valid pipeline combination and asks each one the same set of questions. It logs all the answers and sends each one to an LLM-based judge for evaluation. The judge scores each answer based on relevance, faithfulness, and completeness, and provides an estimate of its confidence. And if the model's confidence is too low, RAGLab pauses and asks a human reviewer to step in. That way you maintain high-quality evaluations even when things get fuzzy. In the end, you get a clear comparison of how different pipeline choices perform, which makes it much easier to pick the best setup for your specific domain. Once the answers are collected, RAGLab scores each one based on 3 criteria: relevance, faithfulness, and completeness. These are each rated on a scale of 1 to 5, and then combined into a composite score. You can see that here in the output summary. For each question, we track the full pipeline configuration, the prompt used, the generated answer, and the score breakdown. We also capture a confidence estimate from the language model that performed the judging on a scale of 0 to 1. If that confidence is too low, usually below 0.2, RAGLab pauses and asks a human to evaluate that answer manually. This process makes it easier to spot high-performing pipeline combinations. And just as importantly, it helps you understand why certain combinations perform better than others. RAGLab is built to be modular. You can plug in different functions and models for each stage of the RAG pipeline: pre-retrieval, retrieval, and generation, and RAGLab will automatically test all the combinations you define. After each pipeline answers the test questions, RAGLab sends the results to a language model judge. That judge scores each answer on 3 criteria: relevance, faithfulness, and completeness. And if the judge isn't confident, the system pauses and asks a human reviewer to step in. I also added tools to help summarize results, like markdown tables that are easy to scan in a Kaggle notebook. Altogether, the system makes it much easier to compare pipeline options and understand what's working best. In the end, building RAGLab gave me a clearer understanding of just how complex RAG pipelines have become, and how important it is to have tools that can help compare those pipelines in a consistent, structured way. I was especially encouraged by how well the LLM-based grading worked. When paired with human fallback, it creates a reliable way to evaluate pipeline quality without needing hours of manual review. Looking ahead, I'd love to add features like more function options at each stage of the pipeline, support for more pipeline branching logic, more detailed metrics, and tracking of token cost and latency per run. The goal is to make it even easier to tune a chatbot to your specific domain, whether you're in healthcare, law, education, or beyond. Thanks for watching. You can read more about this project in my blog post, or check out the code in my Kaggle notebook. I hope RAGLab helps inspire better tools for evaluating Gen AI systems in real-world use cases.